there are two kinds of sequence that are very important, and they have names, which I'll tell you in just a second. Here are examples of each kind. Go ahead and look. They've got the same starting value, but they change differently. So think for a minute if you were going to try and come up with an equation to describe the nth term, or even if you were just going to guess what was the next term in the sequence. Think about that for a second. All right, the sequence on the left is an example of what we call an arithmetic sequence, and the one on the right is an example of a geometric sequence. And if you look at the type of growth that each has, this is subtracting 9 to get the next term. This is multiplying by 1/2. You might have thought about it as dividing by 2, and that's the same. So think for another minute, what family of functions has this type of growth, and what family has that kind? So the arithmetic sequence on the left exhibits linear growth because we are adding or subtracting the same amount to get each new term. And the sequence on the right involves geometric growth, which is a different word for exponential growth. So we're multiplying by the same amount every time to get the next term. But what should the x values here be? I'd said before that the notation that we use is to think about this as being the first term and the second term and the third term. So it might make sense to make this value 20 be the output for the first term, and then we'd have the second term and the third term and the fourth down to the nth term. So let's write the same thing on the other side. So I think you should be able to do this already, but go ahead and try and figure out what should the equation for the nth term look like. So pause it, give it a shot. I'll tell you what I think in just a second. So the way I think about each of these, I mean, you could start with the general equation for a linear function and then plug in points and solve for constants. That's fine. But I think there's a more natural way to think about it. I think about the algebraic equation as a description of how you get to the number you want from a starting number. So for the nth term, I start with 20, and then I need to subtract 9 a certain number of times. So let's think about it. If I want the third term, I'm going to start at 20 and subtract 9 twice. If I want the fourth term, I start at 20 and subtract 9 3 times. If I wanted the 100th term, I should start at 20 and subtract 9 99 times to get to the 100th term. So if I'm on the nth term, I'm going to follow that same pattern. I'll start at 20, and then I'll subtract 9 n minus 1 times. Because n is the term number, so when n was 4, I subtracted 3 times. So if I want to get to n, I have to subtract by 9 n minus 1 times. So that's, I think, a nice way of thinking about it, because it's a very natural way of describing how you get from the starting point to the term that you want. If you want to, pause the video and go ahead and try and apply that same idea here, starting at 20 and dividing by and multiplying by 1/2 a certain number of times. Alright, so I'm going to start with 20, and if I multiply by 1/2 twice, that's like 1/2 squared. And if I multiply by 1/2 3 times, that's like 1/2 cubed. So I'm going to be multiplying by 1/2, and then how many times I want to do it, just like over here, is n minus 1 times. Because if I'm going to the fourth term, I need to do it 1, 2, 3 times. So you can see that really does look like a linear function. This really does look like an exponential. Quick note here, I've written n, but actually this isn't really n. This is really the a sub nth term. Because if you remember, we described this term as a sub 0, and this term as a sub 1, this term as a sub 2, and so on. So this is the way of describing what is the nth term. I want to know what is a sub n, and that's the equation that tells me. So just that was a little notational thing. Also, I wanted to note, again, that this doesn't have the form of a linear equation that you're used to. This isn't in like mx plus b form, and it's not in point-slope form, or at least not obviously in point-slope form. But I think this form makes sense for thinking about it as start from somewhere and describe how to get to the term that you want. If you want to, like, this really does make sense if you think about it in point-slope form, and you can think about that on your own. So let's this was built from a specific example. Let's generalize this one step. We know that all arithmetic sequences have to start from somewhere and have some kind of constant growth. So I want to write the general equation. What value should I use for my starting term? I could call it a variable like s. We actually already have a good name for this. It's a subscript 0, remember? That's what we said was our name for the first element. Oh, subscript 0, my bad. Subscript 1. So let's do the same thing on the other side. And then we said that the growth is a constant growth for the arithmetic function. So let's make that plus d. You could name that whatever you want. So here we've got, so this was a sub 1. This is going to be a sub 1 plus d. This is going to be a sub 1 plus 2d's, because I went 1, 2, and so on. And then here we've got a sub 1 plus n minus 1 d's. And that's a generalized version of the one that we had just done. If you want, you can pause and try and do the same thing here. Here I'm going to use a growth rate of r, r meaning rate. And we've got a1 times r, and then this is a1 times r squared. And in general, we have a1 times r to the n minus 1. And both of these are equations for the nth term, a subscript n. So all of the basic problems you're going to get all have the same strategy. It's the usual algebraic strategy. You know some things and you want to know something else. So you plug in what you know and you solve for what you don't. So for example, let's say I want my initial term to be 3 and the 1980th term should be 2019. And I could imagine that as an arithmetic sequence or a geometric sequence. So I've told you some information about what you know about the sequence in general, but I didn't tell you what the growth rate was for either. So I could ask you to figure out the growth rate, or I could ask you something different, like what is the 100th term, for example. But in both cases, you plug in what you know and solve for what you don't. Give it a quick try if you want. Pause the video, and then I'll show you. Alright, so in this example, n is 1980, because that's how many terms I have. And my initial term, a sub 1, is 3, and I know that my last term in this sequence is 2019. So I can plug in what I know. I know that a sub n, my last term, is 2019. I'm starting with 3. Because n is 1980, my n minus 1 is going to be 1979. And then the thing I don't know is, what does this growth look like? So that if I take 2019 little tiny hops, if I take 1979 little tiny hops, all end up here. So you can solve for the equation. I'll subtract 3, 2016. Do you guys remember 2016? Yeah. And then divide by 1979, and so d equals 2016 over 1979. And that seems like a perfectly okay form for the answer. And then if I wanted to know what's the 100th term, well great, you've just solved for d, you know what your initial term is, so now your new n is 100, and you're trying to solve for a sub 100. But you know this, and you know this, and you know that, and so you can just plug and chug. For the geometric example, it's very much the same. We've got 2019 is 3 times our growth rate, because that's what we don't know. That's the r here is sort of like the d over there, remember? Here d is a constant additive growth. Here r is a constant multiplicative growth. Multiplicative. So same kind of thing. Let's solve. So here I've got 2019 over 3. This actually is divisible by 3. What is it, though? Okay, hold on. Okay, I just looked it up. It is 673 equals r to the 1979. So now you can just take the 1979th root, the 1979th root of 673, and that's your growth rate. 1979, 673. What number is that? Let's do it on the calculator. And there you go. It's 1.0032958. So I think that covers maybe the first two quizzes of the Khan Academy stuff. And you're welcome, of course, to look at all those materials, but I thought that they could be condensed. I'll try and post some more advanced kind of questions to think about, because the Khan Academy stuff is really foundational. It's important to understand, but it's not going to stretch you. Good luck, everybody.